section. All right. So by popular request, we're going to quickly review chapter 2.6 before we start 2.7. And let us apply our akdc on an unfamiliar function to really test if you understand this mathematical system of transformation on x to the power of 3. Remember, in case you're joining us or you're watching this video and you get worried, oh, you can't see it. There you go. I'm gonna have to fix this calibration then. Okay. X to the power of 3 is not evaluated on a test. Okay, I am not going to test you on it. You don't have to be familiar, but it's a bit of a challenge to see if you really get it. Also, I'll start this off for you. X to the power of 3, my accuracy points are, and I'll write it here, 0, 0, 1, 1, and then 2, 8, because 2 times 2 times 2, that is 2 to the power of 3, x cubed. There. And then 2, 3, 4, 5, 6, 7, 8. This is a very rough sketch. And it's going to be 3, 4, 5, 6, 7, 8, something around there. Very similar to a parabola, but you can probably figure out why one side's negative because it's a cube, it's not a square. Okay. Speaking of sketches, I have something for you. Quick story. Every time I learn that I am teaching a grade 11 or a grade 12 class, I go around, I look up the company and I buy one of these. It is a Post-it note, but it has a graph on it. I find that this is very important for grade 11s and grade 12s because, what do you call it? This is the first year where you're just learning to sketch and sketch really fast. It's to the point where one day when you're writing with lined paper, you should be able to just draw 2 straight lines with a ruler and roughly sketch what the shape looks like so you have a better idea, a better understanding, and you can talk about it. But until you get to a point where you're comfortable enough to do rough sketches, you might gain more confidence from drawing very accurate sketches. So what I'm going to do is pass out these to you. Again, when I find out in the beginning of the year, I go ahead and order one for all of my students. But since it's a quadmester, I don't have time for that. By the time I get it ordered in, we're going to be done the quad, right? So this is what I have left over from previous years. It's not much, and it has to share between 2 full classes. So I'm going to split this in half, and you can have it. Please, don't feel like you need to save it until last minute. Just use it when you need to for your homework. I will. Okay. Use it for your homework whenever you need it, especially if you think it would benefit from, accurate graphs. If you use it up completely, I might have some extra. So, don't feel shy for asking for more, but don't waste it because I don't have that much. Okay, this is my last bit. Okay. These piles are, if I buy in bulk, just under $1 a piece, but it's sort of like, think of it as an investment I make for my students every time I do grade 11 or grade 12. You might be able to find it or buy it yourself as well. So just so you know, it's not that expensive and it can be useful to you. Okay. So I have one. It is yours to keep. Okay. If you want to know, no problem. If you want to know, or if you just want to be careful with it, the glue is actually on the left and right side only. If you want to take one, there's a little unglued portion on the middle section. Just slide it right out. Stick it on your question sheet. No problem. No problem. Stick it on your homework sheet, your paper, whatever it is you're doing your homework, and then draw it out. Okay? Again, there's a lot of sketches going on in grade 11, so I think it's useful. All right, let's do this. I need some numbers. What is my equation today? What am I doing today? I need some random numbers. Starting from Anna, let's just give me some numbers. Try to be nice to me. Okay, don't give me like 1/10 or something like that. okay, because I don't have enough space. Okay, what is my a value? 2. Nice. Will, what's my k value? Oh. How about we do? Can I flip it? Let's throw a fraction in there. Let's do a 1/2. Okay. D, Lynn, 3, and Cindy, 4. Sounds about right. No negatives in there. That's okay. I think you guys can figure out the negatives. All right. That means the function that I gave you was 2. Yeah. 2 half x minus 3 cubed plus 4. Now, if you look at that straight, that is a function that you've never seen before. It makes sense for you to be like, what the heck, and feel a little bit uncomfortable or a little bit scared about it. But it still follows the same system. So I'll try to use different colors to help you out. Let's start with the a value and continue moving from left to right as if I was reading a sentence in a book. Okay, a value. Someone want to give it a shot. What does a do? Josh, go ahead. Close. It is the vertical stretch. So it's not the x values, but y values. Okay, so 0 times 0, or 0 times 2 is still 0. 1 times 2 is 2. And 8 times 2 is way up there, which you cannot see because it's behind on the board. You know what? I'm going to do it. Oh. Really? Is it fixed? Oh, it is fixed. New. Contrast, sharpness, color adjustment? No. Extended settings, control panel, zoom, keystone, power consumption, signal. Huh. Brightness, contrast, sharpness, auto reset. No, not that one either. It's not correct. Huh? Huh. I guess I can't move it up down. That sucks. Okay. I'll try to draw it so that you know where I'm talking about. 16. Right there. Okay. 16, really up high. And then 2 times a -1 is -2, and 2 times -8 is -16. My new function is going to look like 10, thicker line. Oh. Oh my gosh. All right. Sounds like a plan. Okay. Next, I'll use blue. We are working on this part right here. What happens? Someone else. We were on then Josh. Yep. Oh, you're right. Now's a good time to say that. Now that we've done the stretch, let's do that in red. It is a vertical stretch by a factor of 2. And this would be, on the graph, we would call that 2x cubed. That red line is 2x to the power of 3. So let's work on the blue. Yes. So what would the blue be written as? horizontal something. Who's around? Who's after Josh? Just because Josh went. Monica, what do you think? Close. Because it's a factor of 2, we're multiplying by 2. Visually, what's happening to it? We're... Oh no, did you say stretch? You're right. It is a horizontal stretch. Because visually we are expanding it, horizontal stretch, by a factor of 2. We are multiplying all the x values by a 2. So let's write it out. This one would be, so my y value, so my x value here is still a 0, but my red point right here, the x value is a 1. I'm multiplying it by 2. It has been stretched to the right. Right here, the x value is a 2, so now it becomes a 4. The x value is a -1, it becomes -2. And down here, the x value is a -2, becomes -4. Let's see if I could draw that nicely. Oof. Oh, so close. If you follow along with me, do your best. I'm really trying here. Okay. And oh, okay. So that blue would be 2, 1/2 x to the power of 3. So it has the vertical stretch, it has the horizontal stretch. Now, again, I know that this is going to be moving 3 to the right and 4 up. To save myself some time, I'm going to do it all at the same time. It's going to be a horizontal shift, right 3, and vertical shift up 4. And I meant to do that in green. And I'm going to also highlight this in green. And now I will draw in green. The 0 becomes 1, 2, 3, 1, 2, 3, 4. The blue 1, 2, 3, 1, 2, 3, 4. This blue 1, 2, 3, 1, 2, 3, 4. Something like that. I'm going to draw this in before I lose track of where my points are. Oh man, this is so hard on screen. Okay. And I'm going to lose you here, but 1, 2, 3, 1, 2, 3, 4. It's going to be here. And that point is going to be above the screen, so you won't be able to see it, but I think you can guess. It's going to be like that. And that is 2, 1/2 x minus 3 cubed plus 4. Same system. And I'm sure your drawing's a lot clearer and less messy than mine. Yes, Claire. Sure. So according to this, my 0, 0 became 3, 4. My 1, 1 became, you know what? I'm going to do the thing. This is a good opportunity for me to show you how it changes by mapping. So this became 1, 2, 3. That's 4. No, 1, 2, 3. Yeah, that's 4. 1, 2, 3, 4. 4, 5. Right. And my 2, 8 has become, wait, no, what am I doing? It's not 4, 5. So this point is now 1, 2, 3, 1, 2, 3, 4, 3, 4. My next point would be here. It would be 3, 4, 4, 4, 5, 4, 5, 6. Is that correct? Yeah? Okay. As you can see, this is a very good example of how even if you sketch it, it's not good to figure out whether your dots are correct. Now might be a good time for me to apply akdc mathematically. If you remember on our akdc summary page with the boxes, I gave you things like x and y becomes, x, a, y, or whatever. If you apply all akdc together, you can say that the x becomes 1 over k times x plus d, and then a times y plus c. If you take your original parent function points and apply these operations on the x and the y, you get your transform points as well. In other words, let's try it. So 2, half, 3, and 4. I'm going to clear all of this. A is 2, K is half, C is 3, D is 4. So that means 1 over K would be a 2. X, 2y becomes 1 over kx plus d, ay plus c. My parent function had a 0, 0. That means it becomes 2 times 0 plus 3, comma, 2 times 0 plus 4. This becomes 3, 4. My parent function had a 1, 1, but that would be a 2 times the 1 plus 3, 2 times the 1 plus 4. My parent function now has 5, 6. And I'll do one more. My parent function had 2, 8 to it. 2 times the 2 plus 3, and 2 times the 8 plus 4. The point that was really, really high up in my graph would be 7, 20. So you can also do it this way. Okay? They're one and the same. Hoping you'll be able to, develop that practice. Any questions? Some of you might have some, but you might think that you need to wait and practice before you ask because you're scared that I've already covered something. All right. Let's give yourself a chance and then reach out. Yes. Sure. One more? Do you have? Sure. How about you give me the equation itself? I'll do it really quick. Okay. This? Okay. Not a problem. First things first, identify your akdc. Would you do that for me? Sorry. Yeah. You know what? What's the parent function? Yes, it's a reciprocal. What is A? What is K? What is D? And what is C? Good? Good? Almost? And I'll tell you why. Good. The reason why you were not quite sure, you were not quite correct on this one is because whatever the number is multiplying with x, you got to factor it out. This actually becomes plus 1. Yeah. So it moves to the left, not the right. Okay. I'll warn you again. Guaranteed. Just because I can, I'm probably going to add that in there to see if you were paying attention. So always look to see if you need to factor the k first. It's going to be on the test. It's going to be in March, sometime in March. It's going to be there. Okay. I have it recorded now, so you can look at this video and be like, oh yeah, he said so. Okay. Let's do this. Starting from the top, the parent function looks a little funky, but I am going to be really, really quick with it. I'm just going to be just really quick. Zeros, not 0, 0. What am I saying? 1, 1, 0.52, 2.5, negative 1, negative 1, negative 2.5, negative 0.52. This is my parent function. And I will draw a dotted line. I can't draw dotted lines, can I, with this? In pink to show that I have asymptotes. Yeah. These are my asymptotes. Okay, let's start left to right. Excuse me. Left to right. My A value is a 3. So all my Y points, Y values are going to be multiplied by a 3. Let's start just left to right. This is a 0.5. So it's going to be 1.5. 1.5. The negative 1 becomes a negative 3. And negative 2 becomes negative 6. And that makes sense. This is a vertical stretch, right? So it's pulled down. With me, Josh? All right. And the next one, the height is a 2, so it becomes 6. The height is a 1, so it becomes 3. The height is a 0.5, so it becomes 1.5. And the blue, this also makes sense because it's a vertical stretch. The orange has been pulled up and down. Next, I have my K value. Oh, would you like me to write it in words as well as an exercise, or you're good? Do you want me to type it as well? No, you're good? Okay, you just want to see the graph? All right, now I'm done the A value. Let's do the K value. I'll use red. Let's do the K value. All my X values are multiplied by negative 1. So 0.5, oh, sorry, let's do from here. This is negative 2, it becomes positive 2. Negative 1 becomes positive 1. Negative 0.5 becomes positive 0.5. Mirror image. Yeah? Now the blue, same thing. 0.5 is negative 0.5. 1 is negative 1, and 2 is negative 2. Now it's there. This is actually looking really pretty. I like it. Now that I have done that, I need another color that I've not used before, neon greenish. I will do a movement to the left and movement up by 3 in one go. Except there's way too many points. So here's the cheat that I was mentioning before. If I move to the right by 1, my asymptote will move to the right by 1 as well. Now that everything is dotted, how about I just do a solid line? Oh my goodness. Is there a way for me to, okay, how about this? Nope. For me. That doesn't even show up. Okay, let's do this. My new asymptote will be here because I moved everything to the right by 1. And I'm moving up by 3, so my new asymptote will be here. Yes? Pardon? Yes. Yes. You are right. And then 3. There it is. Oh my gosh. Thanks for catching that. That would have ruined our beautiful picture. Okay, and from there, try to visualize our very last function was the red one. That red of this, I want you to replace it, move it to where the black asymptotes are. So you move it 1 to the left and 3 up. So with a solid dark line, I will draw. It would be, this part is basically 1, 2, 3, and 1 over. This part is 1, 2, 3, and 1 over. This is 1, 2, 3, and 1 over. It goes like that. And the same way, again, if this is a rough sketch, I will understand if it's not up to par. 1, 2, 3, 1 over. 1, 2, 3, 1 over. There it is. Oh, yeah, almost. And then I had to shift it, right? But yeah. So again, the system. Guys, take a look at the graph you just graphed. Literally, a week ago, you would have been like, I am not touching this with a 10-foot pole. But it's actually just following the same system. I'm hoping you feel that much more confident, that much more accomplished, right? Being able to do something you haven't been able to do before. But to pat yourself on the back, tell your parents that you deserve a reward, and get stuff for it. Yes. Okay. It's not that it's wrong. I simply took the reflection. So it's a little funky because it's a fraction. It's a little funky. Having a numerator on the top or the bottom results in the same answer. So instead of doing a -1 here, I think I just did a -1 there. So take, right? Sorry, a -3 there. So take a look. Where's my original? My original was here, right? So it's here. If I flip it horizontally, it's this part and this part. But if I flip it vertically, it's this part, the same quadrants. So for the reciprocal, it's very unique. No, it all depends on how you interpret that. A -1 here could be just -3. Yes, absolutely. I'm glad you're here, Josh. So we can go through all of this. I'm being totally honest with this. Okay, by domain square, let's try to use a solid color. Okay, domain is, of course, it's a solid line, so it's x belonging to R, real numbers, such that any x value is okay on this side, the positive side. Any x value is okay on the negative side, but what's not okay is the x value where this dotted line is. Where this dotted line is. And that particular value is matching the d value. It is when x is equal to -1. So I don't have the symbol for that. Let me just write it. X cannot be a -1, but everything else is fair game. In the same way, for range, y belongs to real numbers because it is a solid line, but we cannot have any value, any y value touching this line. And so we say, oh, that dotted line corresponds with the c value. Y can never be a 3, but everything else is good. And if you want to hunt it, it makes sense. Take a look at my original function. If x was a -1, what does that make this binomial? 0, and we can't have that. Also, because a numerator is a 3, right? This will, numerator is not a 0. This fraction will never be a 0, which means 3 plus something will always be there. It will never be 3 plus 0. That's why y can never be a 3. It's always 3 plus something. Okay. Is that good? If I confuse you with that last bit of what I'm saying, just look at the asymptotes, and that is what your restriction is going to be. Yep. Yes. So that's why we call it a vertical stretch. Y, the y values is up and down. Only I. So again, this is why I say x, y is always going to be, the x is going to be affected by the k with d, the horizontals transformations. X is multiplied by 1 over k, and then it's added with the d value. And then the y value is always going to be multiplied with a and then added to c. I may not have written this together, but I did write pieces of it in our little box, the box summary. This is good. Any questions? Any more questions? I think that was good. Like I think we've like beaten it through enough times for you to at least go home and have more practice with it. At least on your own, you'll feel that much more confident. Think we're good? Okay, so let's move on to the quick and simple lesson for today.